So Abdul has also joined. Let's start the session. Okay. So everyone, so in this chapter, so Galvin, Aisha, Abdul, please do switch on your videos which are fast.
I'm on a second, sir. My net is lagging with
Acha, check. Abdul, are you there?
Yes.
Please do switch on the video. Aisha, you as well.
It's not working. Like,
Sure.
yeah.
So let's start the class. So whenever you join the class, please try to join with a device in which your camera is working. बिकॉज देखो अगर मैं क्लास में देख नहीं पाऊंगा, आपको रिविजन क्लास है, वैसे भी आप मतलब बहुत कम अटेंशन से लेते हो, एवरीवन आई नो दिस थिंग, बट try to use a device in which I can see your basically screen, your face, so that I can get to know yeah you are there in the class at least. ठीक है, so try to use that device, और even मोबाइल फोन हो कुछ भी हो तो मैं, क्योंकि इस क्लास में हम लोग न्यूमेरिकल ज्यादा नहीं करते, मेरा ही ज्यादा काम होता है इसमें. ठीक है.
Yes.
Okay, so we have the first, this is the chapter, that is your electricity chapter, in which we are going to study this thing. We have, according to electricity, we have two types of electric charges, that is proton and electron. Proton means positive charge, electron means negative charge. So similar charges repel each other. This is the first property of the charges, and opposite charges attract each other. Yes or no? Okay. And
Yes.
electric charge is quantized. It means that the charges are present in the whole number. It means that they are in integral numbers. They are not in fractions. Okay, quantized means that. Next thing, charge on one electron is negative 1.6 into 10 to the power minus 19 coulomb. This is the value of one basically charge of an electron. And if you basically take the positive of it, it would be 1.6 into 10 to the power minus 19 coulomb. That is the charge on the proton. Okay. Next is mass of the electron is 9.1 into 10 to the power minus 31 kg, and mass of proton is 1.67 into 10 to the power minus 27 kg. Okay. Next thing that we have is basically SI unit of electric charge is coulomb. Okay. Let me know the answer of this question using this formula. Q is equals to NE. Wait fast. And so, yeah, then. No answer by anyone. ठीक है, देखो it's nothing but the value would be 6.25 into 10 to the power 18 electrons. ठीक है, so the number of electrons in 1 coulomb of charge would be 6.25 into 10 to the power 18. Is that clear?
Yes.
Yes.
ठीक है, okay, so this is basically your basic thing. ठीक है, and 1 coulomb of charge is equals to this number of electrons. ठीक है, and this is the explanation. Now let's talk about the next thing, that is basically conductors and insulators. So conductors are those materials which allows the electron to flow through it. ठीक है, simple. This is the simple definition of the your conductors. And the examples of conductors are metals, graphite. ठीक है, next is the insulators. ठीक है, insulators are those material which does not allow the electron to flow through it, like wood and plastic, rubber. So these are the such materials which are a good example of insulators. Is that clear to all of you?
Yes.
Yes.
Good. Okay. So the presence of free electrons in a substance make it is a good conductor. If the electrons are good, if the number of electrons are more, then it will be called as a good conductor. Clear all of you? Okay.
Yes, sir.
Good. Next is our second electric potential. So what is electric potential basically? So electric potential at a point in an electric field is defined as the work done in moving a unit positive charge from infinity to that point. Suppose there is an electron present over here. So if there is an electron, obviously there would be some electric field of this electron, yes or no everyone, in which the electric force will be observed. Yes or
Yes,
no? Okay. So if you try to take one more electron and in this region, you have to do some work because this electron is placed at infinity. If you are carrying something, you will do some work. Yes or no? Right, Abdul, Aisha, and Galvin?
Yes.
yes, sir.
Yes.
Okay. So the work done that you are doing to carry a unit positive charge from infinity to that point is called your electric potential. Okay. So electric potential is a scalar quantity. That means it only depends on the magnitude. It does not depend on the direction. Next thing, SI unit of the electric potential is volt. That is V. Clear all of you?
Yes.
Any doubt
Yes.
Yes,
so
sir.
far?
No, sir, no doubts.
Now let's talk about the potential difference. What does it mean basically? Potential difference is the difference between the 2 points in an electric circuit is defined as the amount of work done to carry the unit positive charge from one point
Yes,
to another point. Suppose देखो, a charge is taken from infinity here and another charge is taken to here. Okay? So 2 points are present. So if what the work done that I will do to take the charge from A to B or vice versa if you reverse the process, or from point B to A. So that is your potential difference. Is that clear? Potential
yes, sir.
difference is also called as the voltage. Okay, voltage. And the SI unit of potential would be volt itself. Clear all of you?
Yes.
Yes, sir.
Yes.
Okay. Acha, one more thing. The potential difference is calculated like higher potential minus lower potential. Okay? Higher minus lower. Clear all of you?
Yes,
And the potential difference is measured by the instrument called voltmeter. And the potential difference per voltmeter is always connected in parallel circuit, because in parallel circuit, the potential remains same at each point. Yes or no?
Yes.
yes, sir.
Okay. And potential voltmeter should have very high resistance. Okay. So if you are basically have a voltmeter, that it should have very high resistance. Clear all of you?
Yes.
Yes, sir.
Next is the voltmeter should have very high resistance. If we talk about the definition of 1 volt, what does it mean? So that says the potential difference between the 2 points is said to be 1 volt if 1 joule of work done is done in moving a 1 coulomb of charge from one point to another point, that is 1 volt. ठीक है? ठीक है, इसको जरा
Yes.
कैलकुलेट करो, इसका आंसर मुझे बताओ. If two potential points, electric potentials are given, how to calculate potential difference and then work done? Okay, Aisha. Alvin, Abdul, do it fast. Yeah, Alvin. Abdul, answer. The answer would be 20 joules. Okay. Because if you subtract the higher potential minus lower potential, that would be 10 volt. 10 into 2 coulomb of charge is 20 joules. ठीक है, इसको जरा calculate करो. Let me know the answer. ठीक है अब्दुल. Anybody else? Okay, Calvin. Right. Yeah, very good. The answer is 6 joules. Just you have to multiply it, okay, with 1. Let me know the answer for this one. Do it fast. Okay, sure. Yes, the answer is 40 joule. Last question and let me know the answer. Yeah, that's good. That is 12.5 volt. Yeah, that's correct. Okay. Now let's start the next topic, that is electric current. So now let's understand what does it mean. So electric current is basically nothing but the magnitude of the electric electrons flowing through a circuit in a unit time. Okay. So in 1 second, how many numbers of electrons are flowing through it is called nothing but the current. Okay. So I is equals to Q by the key that T, that is nothing but 1 ampere. Okay. So electric current is the flow of charges through a conductor, okay, such as a metal wire. So SI unit of electric current is ampere, right, everyone? And how do we define it? So when 1 coulomb of electric charge flows through a conductor in 1 second, the current is said to be 1 ampere. Next is electric current is measured in an instrument called ammeter, and ammeter is connected in series. Okay, ammeter is connected in series with the battery, and ammeter should have very low resistance, because if the resistance would be high, then the ammeter will not give the correct reading. Okay, because it will hinder the current to flow through it. Next is, okay, this is also a unit called milliampere, that is 10 to the power minus 3 ampere. Clear everyone? Calvin, Aisha, and Abdul?
Yes.
Yes, sir.
Good. If you talk about the direction of electric current and electrons, that is, suppose initially there is no there is nothing attached with the wire. This is a normal wire, like, okay. So in this you can see the electrons directions are random. They are just colliding with each other and walls, and they are just randomly moving. But once the electric potential is applied through the wire, you can see all the electrons are aligned in a attention manner. Okay, and they are pointing towards positive, because they are attracted towards positive due to the properties of electric charge, right? Unlike charges attract each other. So okay, so the direction of electron in the inner circuit, inner wire, this is wire now. So what is happening inside the wire? It is attracting towards the positive. It means that the direction of electrons are from positive to from negative to positive. But direction of current is positive to negative, because potential flows from positive higher to lower. So positive is at higher, negative is at lower. Clear? So that's why direction of electrons are opposite to electric current. Clear all of you below?
Yes.
Okay. So direction of electron is from negative terminal to positive terminal in a metallic wire. The simplest way to maintain a potential difference between two end of a conductor is to give a continuous flow, that is nothing but a battery. So conventional direction of electric current is from positive to negative terminal through the outer circuit. अच्छा चलो इसका जरा calculate करो आंसर, let me know the value of it. Okay, Aisha. Okay, Galvin. Abdul, sorry. Galvin, answer. Answer would be 300 कूलम. ठीक है, जरा इसको कैलकुलेट करो. लेट मी नो द आंसर. Abdul and Galvin. Aisha, answer. Yeah, that is 324 कूलम. Good. लास्ट क्वेश्चन आई थिंक. हाँ, लास्ट क्वेश्चन. जल्दी से बताओ इसका आंसर. Any answer? Check the Galvin. Check Aisha. Yeah, that is 1200. 1200 joule. Okay. Chalo, good. Now let's talk about the Ohm's law. So what does it mean? So what is the Ohm's law? So Ohm's law is nothing but it gives the relationship between the current and the potential difference. It says that the potential difference across the ends of a conductor is directly proportional to the current flowing through that conductor at constant temperature. It means that the temperature should be constant of such in the scenario. Okay, is that clear?
Yes.
Yes, sir.
Good. Okay, so the statement is V is equals to IR. V is directly proportional to I, and if you remove this proportionality sign, it would be VIR. Okay, so R is equals to V by I. It means that so this the ratio that of the potential and the current is called potential the resistance of a conductor. So now let's talk it about so the ratio of the potential difference applied between the ends of a conductor. Just a second. Ends of a conductor and the current flowing through it is called the resistance. Is that clear, all of you?
Yes.
Yes, sir.
Chalo, good. The electric current is directly proportional to the potential difference and it is inversely proportional to the resistance of the circuit. Okay. Now, next thing is if the potential difference of a conductor is double, then the current flowing would be also doubled. But if the resistance is double, the currents get half because it is inversely proportional. Okay, next thing we have that is graphs of Ohm law. Ohm's law. These are very important. How? So V versus there are two graphs, that is V versus I graph and I versus V graph. So if we take V versus I graph, V is on the y-axis, I is on the x-axis. So that would be VI graph. So in that case, y by x would be V by I. So that is nothing but your R. It means that the slope of the your slope of the V versus I graph gives you the R. Okay, that is your resistance. It means that higher the slope, higher the value of R would be. It means that higher the resistance of that circuit. Okay, and if you talk about I versus V graph, so y axis is I, x axis is V, so I by V. Okay, so that is 1 by R. It is the inverse. That means higher the value, it means that higher the fraction, lower will be the value of the R. So steeper the slope, lower will be the value of R because it is inverse of it. Is that clear, everyone? Do let me know.
Yes, sir.
Good. Now let's talk it about so resistance. The property of a conductor due to which it opposes the flow of current is called resistance. So the resistance of a conductor depends on length, thickness, or nothing but area, nature of material, and the temperature of the conductor. And the SI unit of resistance is called ohm. And one resistance of a conductor is defined as the when the potential difference is 1 volt and applied to it, and the current flowing through is 1 ampere. This is called 1 ohm of the resistance. That clear to all of you below?
Yes.
Clear?
Yes.
Any doubt?
No.
No, sir.
Good. Chalo. So try to solve this question and let me know the answer. आंसर। सिंपल आंसर 5.5 होगा। इतना टाइम क्यों लग रहा है आपको? इसको कैलकुलेट करो, सेकंड वाले को। आंसर फॉर द सेकंड क्वेश्चन। ठीक है, ठीक है ईशा। गालविन, अब्दुल, आंसर।
Sir, one second, sir.
राइट आंसर। ये वाला कैलकुलेट करो, लेट मी नो द आंसर। Answer. देखो, answer would be 1.7. If the potential difference is half, that means the current will also get half according to Ohm's law. So that's why it would be 1.7. Is that clear, all of you?
Yes.
So why didn't you reply at all? Nobody?